Hello there. In this video, we're going to talk about implementing simple if-else blocks in YASM x86-64 assembly. Although, if you're writing in a different assembly language, this video will probably still be useful to you because I'm going to explain the design pattern for how we can achieve that at the assembly level. So, x86-64 YASM assembly, also known as AMD 64 YASM assembly. And, okay. So if you have not seen my other videos about how to do conditional branching in the first place, you probably want to go check that first because that knowledge is required for this video. There's also a lot of other stuff that I'm just not going to explain in this video, such as creating a makefile, compiling and linking your executable, and so forth. So see my other videos where all those concepts are explained already. For now, I'm just going to show you how to implement a simple if-else block. So for starters, maybe let me draw a little bit. Suppose we had, let me get rid of this thing and then I'll just do a regular notepad. Suppose we had a higher level language, just so you know what I'm talking about. Suppose we had a higher level language and we wanted to say if, some expression is true. We wanted to say if expression is true, then print, it was true. Anybody remember that old movie, Little Nicky? Somebody got exploded and then the guy next to him goes, "It's not true." Okay, it was not true. So this is the basic idea of what we're going to implement in assembly. I'm going to write a full program for assembly to show you this, but you're in C++, you're in C, you're in, I don't know, whatever language you're in, and you obviously know how to use if-else blocks at this point, hopefully. And now we're going to just try to figure out how to implement them in assembly. So it's important to understand that really under the hood, there's a bunch of stuff happening. Surprise, right? Okay, so first off, we look at this expression, which could be, I don't know, let's say 5 is greater than 10, or A is equal to B, or whatever it is that you put in there. You could make a very complicated expression. We're going to use simple expressions for this video. So if we're comparing A to B, we'll end up using the compare instruction. Remember, there are two steps to conditional branching in YASM. We first use the compare instruction against two operands, and then that will end up filling up the R flags register so that we can later conditionally jump based on the results of the comparison. So we do a comparison, and then you can imagine that the beginning of this, the true body, notice how it has a scope. I'm going to just put this brace on another line here to indicate that there is a scope from line 4 to 6 indicating all this code in here is executed only if the if statement was true. And then all of this other stuff is executed only if the original comparison was false, right? So you can imagine now label is something like my if was true. So we can make a label for where that body starts and another label for where the else starts. Label is something like if was false. And then what will happen is we can use a conditional jump instruction after we do our comparison. Maybe I should put compare right here. Oh, I'm using assembly style comments. I should be using C style comments if I'm actually writing C++ here. Let me just do that. Okay, so this is the comparison instruction here. And then here's the beginning of the body of stuff to execute if it was true. You can imagine that there could be many statements here. If it was true or if it was false. Just to prove to you that we can execute like a full body of stuff. So we have a label that designates when that body starts, and then we have another label designating when the else body starts. And then we should have a label that, that designates when the whole thing is over. Label is something like if end or if is done or something like that. So basically what we want to do is to implement an if-else, a simple if-else in assembly. We're going to say, let's do a comparison and then we'll do a conditional jump. Where are we going to conditionally jump? Well, if the comparison was true, then we will just jump right here into this label, the if was true label. And then what will happen is execution will fall through. When it reaches the end, we want to have another jump statement that unconditionally jumps to the end of the if statement. If we didn't, then whenever the expression was true, we would end up executing all of the true statements, and then it would fall through to all of the false statements or the not true statements. So we have to have many jumps in here just to sort of say, let's get into the body and then let's finish and jump out of the body. On the other hand, if the expression was false, then our jump instruction is going to jump, over the true body. So it's not even going to do that at all. It's going to execute all of the else stuff. And then it's, sometimes a good idea if you have another jump here that just jumps to the end, but you can kind of see by the way I've written this out that there's not going to be anything between the end of the else body and the actual, place where we're finished with everything, which means we don't really need an unconditional jump at the end of the else body. We can just let the execution fall through. So maybe if I can draw a little diagram here, I'll say, well, I don't know, I'll do like if, put it in a little bubble, and we'll say that if it was false, we jump to one place, and if it was true, we jump to another place. I hope you've already started to understand this by now. So we'll say if the expression is true, we jump here. If the expression is false, we jump over here. And so true would be saying, let's jump to the if was true. So we're going to jump to if was, I'll put a T there because I'm running out of space, if was true. And then if it is false, we jump to if was, I'll put an F, false. And then at the end of the true, we jump to the done label. So I'm just going to put done maybe down here. So at the end of the true, we just unconditionally jump to the done area. And then at the end of the false, we jump unconditionally to the done area as well. Here's something interesting though. When we have a comparison instruction and then we have a conditional branch instruction, let's say A equals B, we did that comparison, and then we wanted to jump into the true area if A equals B was true. So that means we'll say jump equal. So if A is equal to B after we compare, well, let's say A comma B. We're going to use registers when we come to the code. We'll say compare A and B, and then jump if they're equal to some label, and we're going to jump to if was true, right? But the conditional branching instructions, they only jump to one potential place or fall through. So if the comparison was false, meaning if those two things were not equal, then we're not going to actually be able to jump to a different label. We're going to simply fall through to the next instruction. So in that case, the very next instruction would get executed. Let's just put a jump there that jumps to the else. So we'll say jump if was false. Meaning we compare A and B, and if the two things are equal, we'll jump into the true block. Otherwise, we fall through to the next instruction, which that's a very poorly written J, but we're going to unconditionally jump to false. So if we did not jump to the true area, we fall through to the next instruction where we will always jump to false. And that implements the diagram that you see up above. I mean, if we have if statement, we compare, maybe I'll do, A equals B. We jump to true, if was true, and otherwise we end up falling through and then jumping to if was false. And then at the end of both of those, we have an unconditional jump instruction that jumps to the done. So I'll put J and P down here just to let you know, at the end of each of these blocks, we can imagine that they are jumping out of themselves at the very end to the done area. Maybe I'll put an arrow here so that we know both of these jumps end up jumping to the done area. That's the basic idea for how to implement an if-else block, a very basic one. We're going to do more complicated ones later. But for now, we kind of have the idea down, I think. Let's look at some code. Dang, I blew 10 minutes already on that. Okay. So I'm going to copy paste some code from my solution here. This is not like a beginner's assembly video. If you need to learn how to write assembly in the first place, how to compile, link, create a makefile, and so forth, you need to see my other videos first. But for now, we're just going to assume that you know how to make a data section in YASM. And we're going to say, let's make a bunch of strings. So first, I'm going to ask the user for an integer, and then I'm going to make a bunch of decisions, like I'm going to do, an if-else block, to test what kind of number they put. Did they make a number that equal 1 if it was equal to something. Oh, did I ask twice? I can't remember what I'm doing. But basically, we're going to print something if their number was equal to something else. We're going to print something if their number that they inputted was equal to 5. We're going to print something else if their number was equal to 6. We're going to print again something else if their number was less than 10. We're just going to do a bunch of stuff. And then, wait, isn't this the complicated example? Oh no, I think I am using code for my more complicated example. Else, less than 10? I don't know, maybe this is the simple one. Let's double check. I guess if I put more complicated code in here, you'll probably be happy, but whatever. I thought this was going to be a simple example. So I'm just defining strings at this point and, you know, file descriptors and system call codes, stuff that is covered in other videos. Now I'm going to start my text section. So my text section begins with a declaration that I'm going to use 2 external functions. So this video is not about this library that takes input and sends output. I have other videos for that, but basically I'm just using a library that lets you type an integer into the terminal, and then it will print a different number to the terminal for you. So you can imagine if you wanted to follow along with this code at home and you don't have this library, you can just hard code your numbers just to prove to yourself that you can get it to work, or you can use a different library. If you have a hybrid program and you're linking against GCC, you can just use scanf and printf pretty much. Those take a little bit more work to do, but you can do it. Anyway, so our entry point is going to be called if-tester. It's a function called if-tester. Again, this is a hybrid program, and hybrid programs are not covered in this video, but you can imagine that there is a C++ module elsewhere in my source that is just going to call on a function called if-tester. And so that's why I'm marking this as global, so that other modules in my program can call on if-tester. So it's just a little label that we can jump into, or in this case, call into. Let me go down to the bottom of that. We'll put a return statement at the very end. So now this is officially a function. And notice how I made a note here that says R12 is the user's inputted integer. So that means I'm going to be using R12. And since R12 is designated in the ABI, the application binary interface, as Callee-Saved or Callee-Preserved, that means I have to do a push-pop pair to preserve it, or I'll get in lots and lots of trouble. And my program will crash and everyone will hate me. So I'm just going to call this the Prologue, which my favorite book also calls the Prologue, and then I'm going to say epilogue. And so now we have a function that basically doesn't do anything, but we can at least jump into it. Let's see if this compiles as is. I think it probably will. Yeah, so the driver just says hello. That's the C++ program with the actual main function. And it calls my if-tester function, but nothing happens. The if-tester function returns control to the driver, and then the driver just says, okay, I got control back. So nothing really happened. So now let's ask the user for some input. So again, this is not a video about this library or how to print with system calls. See my other videos if you need help on that. But basically, we're going to print a message to the user, hey, please input an integer. And then we're going to call on a library function that lets them type in a number and then returns it to us in RAX. We're then going to store it in R12. And so, well, just basic stuff, right? So if I run this again, it's going to ask for an integer. Please enter an integer. If I can type that, and then nothing else happens. Okay. Now we can kind of start making more decisions. So I'm going to, let's see, if-test, if-test, if-test. Okay, so what I need to do now is run another function called if-test several times, and I'm going to compare the number that the user inputted. So remember, R12 is the user's input, so I'm going to load that as the first argument of a function call, and then I'm going to load the number 5 as the second argument of a function call. Probably not a great idea to hard code numbers in your assembly. You should probably define them up in the globals or the data section, at least as just regular defines and not numbers in memory. But I'm going to just keep these numbers here just so you can see them more. So 3 times we're going to call if-test, and then also another function called crlf. So first I'm going to paste in crlf. Where the heck is that? Oh, dude. Again, this is not a video about the basics, so you're just going to have to trust me or go watch my other videos if you don't understand what I'm doing here. But I have a function called crlf, and its whole job in life is just to print a new line for me, just because I like to do it that way. So that handles the CRLF call. Now let's make another function called if-test. So I'm going to start that by designating its label right after this block of code here, maybe before CRLF. So we have like a basic if-test function. And here's my prototype, just to remind myself what I'm going to be doing. It's going to take an input, and it's going to take another input for test against me. So the first one is like the user's input. The second one is the number that I want to test it against. They're both longs, which means they are both integers, which means the incoming arguments are going to be RDI and RSI if we're respecting the ABI. And then some notes to remind myself I'm going to be using R12 and R13 inside of this function. So I'm going to start by putting a return statement there, since that is what it takes to make a label into a return, into a function. Then I'm going to preserve the Callee-Saved registers. Again, if you don't know what I'm talking about, see my other videos. We're going to push R12 and push R13 so that they are not ruined for the caller. We call this the Prologue. Then at the very bottom of the function, we have the epilogue, which just restores the registers in reverse order. You've got to do it in reverse order. See my other videos if you don't understand why. Okay, so that's basically a function that can get called. It doesn't do anything. Let me double check that the program still actually works. 66, and nothing happens. We just printed CRLF a bunch of times. Okay, so now we're ready to continue. So let's grab the function arguments. Remember, we were going to use R12 and R13 for the user's input and the number we will test against. Those came into our function with RDI and RSI. So I'm just going to copy those two incoming arguments into R12 and R13. And you're supposed to do it this way. If I keep the user's input in RDI, then the moment I call any other function or system call, I'm just going to lose that data. So I'm going to keep it inside of R12 and R13. So I grab the function arguments, and then I print a begin message just to let the user know that we're going to start, making tests against our number. So this is just basically a message saying, hey, begin the if test. And then print what we're going to check against. So the next thing is, I'm going to let the user know what the second incoming argument was. If you look at R13 here, that was RSI, which was the second argument, so the test against me number. So we're going to check the user's input against whatever we called for the second argument. So I just wanted to print it out. Like we're testing your number against whatever. So that means I need to make another call to my little printing library here. So I'm going to give R13 to RDI, which is the first argument. Notice how we already destroyed RDI. That's why I'm keeping the input in R12 and R13. And then we're going to make that call. And we can just assume everything will go according to plan at that point. And then we're going to print a special message only if something actually happens. So we're going to implement the if-else block in a moment. Let me just run this real fast to make sure it works. 44, and then it says, we're calling the function 3 times, and we're saying the basic test has begun. We'll test against this number 5. So we're testing your input against 5, and then 6, and then 7. And then we didn't actually do anything. We're about to. Okay. So then the next thing is we're going to print a special message only if the user entered the right number. So first off, remember we talked about before, we're going to think about taking a C++ or a C if-else block and converting it into assembly. So I'm sort of placing that in comments for you. So the comparison instruction, I didn't want to put the R12 equals R13 inside of the same comment that lines up with the compare instruction, because the compare instruction, as I've said in other videos already, it doesn't actually check to see if something's equal. It just makes a bunch of judgments against the two operands, and it fills up a special register called R-flags with information that we can later use to decide if the two things were equal or not equal or greater than or less than or whatever. So that's why I chose to put that on the next line. So at this point, we're saying if those two things were equal, and that's how I implement the expression in the middle, then let's jump to a special label called if test if was equal. So you can come up with any scheme you want for your labels, but for me, when I have sublabels inside of a function, I like to just suffix the function's name with an underscore and then start thinking of sublabels after that. So everything's like kind of clean. There's less chance of overlap in labels if you have like a giant module with tons of functions. So I'm going to say this is like my main if that I'm checking, and I'm going to jump to a label called was equal, meaning, this evaluated to true. That means that should be the true part of the block. Let's see, do I still have that code here? Yeah, right. So here I'm going to jump to the true block. So, if was true in the first example that we talked about. So I'm going to say if those things were equal, jump to the code for the true block. Okay. That means I actually need the true block, but I guess we're going to set that up in a second. Otherwise, if that did not jump away, it means that those two things are not equal, so I should jump to the else block or the false block. Wait, do I have else in this example? Oh, okay. This first thing that we're looking at is only if, so we don't even have an else block yet. We're going to do that as the second example. So we're basically going to jump to the done area if we didn't jump into the true area. And then at the end of the true area, we can either jump to the done area or we can let the execution fall through. Okay, so now that means I need if was equal. And if I just copy paste a big giant block of code and try to explain it to you real fast, let's do this. Okay, so we were going to jump to if was equal, if R12 was equal to R13. And then we have this label here, and notice how I've kind of like put a brace here indicating, hey, this is the beginning of the true block body. You should consider doing this too when you're first learning, and even after you've learned, because let's face it, assembly is tough. And so in the true area, I'm just going to print the equality message. I'm going to say, hey, your number was equal to, whatever. And then I'm going to actually print the, let's see, R13 number. So that was, I think, the number to compare against, the test against me number. So that means here in this message, we're going to say, hey, your number was equal to the number that we tested against. So then otherwise, let's see, after that, we'll print the suffix of the message. And so, I just like to make pretty printed messages. So let's see, where's the suffix here? I can't even find it. How about if yes equal to, oh, I should have put suffix instead of the number 2. That would have been better. So what I wanted to do is say your input was equal to, and then print the number. And then after that, print an exclamation, just to prove to you how easy it is to make a pretty message that's formatted nicely for the user, or your professor or whoever. So, you basically just print a number, and then you print the prefix, and then you print the number, and then you print the suffix. Not too big of a deal. So let me go down here. We print the suffix, and then that's the end of the true body. And then since we're done with the true body, we can basically just say, all right, now we're done with the if. So the next instruction that follows is the done area. Again, looking back at the example here, that would be sort of like here after the whole entire block was finished. We're ignoring the else in this code, but you can imagine we'll do that soon. So if the user's number matched something, we execute a true body. If not, we jump to the done area. And if the user's number did not match, then we just immediately jump to the done area so that we don't do the true area. And then we write comments to ourselves to help us remember, oh, look, here's like the comparison, and then here's the body of true. And then the done area is like, we could put another comment if we want. We could say like, this is done, but I kind of think the label is self-explanatory. So let's see if this worked. It's always possible that I screwed it up while I was talking too fast. We'll run it and we'll say 44. Okay, so nothing matched any of the numbers. So let's type the number 6 so that we get a little message on the second one. So I'm going to type the number 6, and you can see it did not match the number 5, and it did match the number 6. So we got that true block executing when we called on that function where the number to compare to was 6. And then it wasn't 7, so we saw nothing there. So now we know simple if blocks. The next thing we're going to do is if-else blocks. All right, so let's see. Not sure if I'm going to cut the video and split this up into multiple parts. Probably would have been a smart idea. Let me know if I ended up doing it. We're at about 25 minutes now, but anyway. So now we're going to look at if-else blocks. So I'm going to start off with another function. I'm going to call it if-else test. So here's the tester. It called on if test, and then I'm gonna, I had the if test function that I did previously, and so now we're just gonna make an if else test function. The if else test, it just has one input, one argument for input, and we're gonna just sort of compare it against different values. We're not gonna call this multiple times with different values to compare against. So that means, let's see, we only need to use one register. So I've designated R12 as the user's input, so that's where we're going to store it, which means we should preserve it in the Prologue. So I'm going to push R12, and then again, if you don't understand some of the basic stuff that I'm skipping over, see my other videos where I explained everything you need to know to actually have this kind of a program. So I'm going to have a function that enters, and it returns at the end. It uses R12, so we will preserve it with a push pop pair. And then the first thing that I should do is grab the user's input from the first argument, and if you're respecting the ABI, that means it should come from RDI. So I'm going to move RDI into R12. Then I'm going to say hello. Somebody remind me that the first part of the program has to actually call this function or nothing will happen. So we're going to say hello. That's just a simple message that we talked about before. And then now we're going to actually implement the if-else block. So it's like a little bit more complicated than just the simple if block. It's going to be this whole example that we talked about before. Let me see. Maybe I should add the calls to this block real fast. So we have the if tester, and then run the complex if-else tests right before R12. Okay, let me just double check that I'm making the call at the right spot here. So we have R12 and 7, and then epilogue. Okay, so now finally in our program, we're going to have a call to the if-else test function that we're just making right now. Okay, so we have that, and let me find that source again real fast. If-else test, we got the Prologue. We take their input, and then we say hello. Okay, so now we need another label that begins the if block. So what we're doing is we're checking to see if the user's input was equal to 5, and then we're going to say something if it was, and otherwise we're going to do an else block on that. So again, I like to write my comparison instructions with a blank expression in terms of the C equivalent comment. So notice how we're checking to see if R12 is equal to 5. I put that on the next block because we're going to jump to the true part of the if block if it equals 5. So that's why I put that there. The comparison instruction pretty much just compares R12 with 5, sets a bunch of values into the R flags registers so that we can later conditionally jump if we want to. So basically we'll jump to the true place if that was true, and then if not, execution falls through to the next statement, which will just jump to the else place. So we need more labels, is what I'm saying. So now we need a body for if the statement was true, or the expression was true, we want to be able to execute the true portion of the if block. So that's this right here. So we're going to jump to if it did equal to 5. You could imagine, making a better label. Instead of equal 5, you could say first else if complicated block, true scope, or true block or something. But I just put equal to 5, basically saying we'll execute this code if it was equal to 5. So again, we're just kind of like comparing, and we'll jump into this label equal 5 if R12 was indeed equal to 5. So that means if it was, we execute all this code right here. We know we're finished when we have the very last line saying, let's jump to finish the if-else block. Again, just to clarify, we do the comparison first, and if the comparison was true, then we'll jump into the true area. So, we'll jump into the true area, and then all of these instructions get executed. But if we don't have a way to jump out of that block, then whoops, all of the else statements are going to get executed too, right? So we don't want that. We don't want to execute both the true and the false statements. We want to have a jump instruction at the very end. I'll put JMP, just so that we jump to the end of the if-else block. Jump to the place where it's just all over and finished. Okay, so now I'm going to look at, whoops, turn that off. So we have equal 5, so we're going to jump to if-else test if done. Let me just double check to make sure I'm not forgetting anything. Oh, we need to jump here, basically meaning we're going to jump into the else portion. So here we covered jumping into the true portion, you know, the regular top block. Now here we're going to jump into the else portion. We need a label and some code for that. So this is the else 6 begin. I copy that. Oh man, it's starting to get kind of hectic in my brain here. The copy pasting is worse than actually writing the program. So if the comparison was not equal, like if R12 was not equal, then execution falls through to line 216, and then we unconditionally jump to the else 6 begin area, which is like down here. And then we'll print something else. We'll check again. So we're doing like if, else, if, else. Okay, so originally when I was talking about the if-else block, I didn't do like a very complex if-else statement. We'll say A is greater than B, something like that. So I'll just put more code here, just so you know that we can do if, else blocks. But just, you know, again, keep in mind that every scope here that you're going to try to run based on some condition, you just make it its own label and make sure that at the very end of the scope, you jump away so that you reach the very end of all this stuff. Because just as a quick review, if we are just writing in C or C++, only one of these blocks is going to execute, right? Like if A is equal to B, then only that first block will execute. The second and third blocks will not execute. It'll jump after that all the way down to line 21. Only if A does not equal B do we even have the chance of checking to see if A is more than B. If it's false, then we'll have the chance to check the else. And if it's true, we will only execute the code in the line 12 block. You know, imagine there are more statements there. And when that block is done, then we will jump to line 21. So else will only execute if A is not equal to B and A is not greater than B. So just a quick, C++, design pattern review, if-else block review. So we have like an else if here. We're going to say, check if the input was equal to 6. So we just do the same thing that we did before. We compare R12, the user's input, with 6. We jump if they were equal to the else if equals true block. And if not, execution falls through to line 237. We jump to the less than 10 begin block. So this is going to be like really complicated. How many lines did I actually... I think I got excited when I wrote this. Okay, else if equal 6 true. My challenge to you is to come up with labels that are like way easier than the labels that I came up with. All right, so we're going to do this. I can almost guarantee that when I'm done copy pasting everything, something is not going to compile because I forgot a label somewhere. Else if equals 6 true. Okay. So what's happening here? Again, so at this point, the first if expression was not true. R12 was definitely not equal to 5. So we jumped down to else if equals 6 begin, which was here. And so then we just make another comparison to see, well, okay, those two things weren't equal. It wasn't equal to 5. So let's check to see if it was equal to 6 and then do the same thing. If it's true, we jump to yet another scope. If it was false, we go down to line 237 and jump to yet another scope. So here is what will get executed if R12 was indeed equal to 6, and then we're just basically going to say it to the user. And then jump to the done label, meaning like we're totally done with our if-else block. Notice how the first if here, when it was totally finished, it jumped to the done area, and this else if block is also jumping down to the if done area. So eventually, we're going to need that label. Okay, so then next, we're going to check to see if the user's input was equal to a 10. So like kind of the same thing here. We're going to do another copy paste, and we're going to say, all right, so if the user's input was not equal to, let's see, if it was not equal to 5, then we jump down here for our next comparison. We check to see if it's equal to 6. If it was not equal to 6, then we jump down to the less 10 begin line, which is like all the way down here. We do another comparison to see, all right, well, is it less than 10? If it was not equal to 5 and not equal to 6, then we check, is it less than 10? If it If it is, then we jump to the else if equal less 10 true block, which is going to be the next block up here. I made this way too complicated. I realize that now. But it's too late. I'm going for it, man. Anyway, so if that statement is true, if R12 was indeed less than 10, then we jump to this block, and we basically just say that to the user. And then we jump to the done. So finally, notice how this part right here on line 259, it's basically saying if R12 was not less than 10, then we'll jump somewhere else. Notice how it's just else, right? So this is like the very bottom. So I think the way that I wrote this code is we have two else ifs, right? We have like an if 5, else if 6, else if less than 10. So maybe I could do something like this. If R12 equals to 5, do some stuff, else if R12, I think I said 6 just now, right? Hopefully I actually did say 6. Otherwise, if R12 is less than 10, then do some stuff. Otherwise, if nothing else matched, then we'll execute, this block right here. And so again, remember, every single scope has to have its own label so that you know where to jump. And it's also a really, really smart idea for every single scope to have to have a little jump instruction that jumps past all of the if-else stuff. So we'll say like, label, done, so that we can make sure that only one of these blocks actually executes, which is how you're supposed to imagine C and C++ work. And so it's just complicated because there's a lot of stuff to copy paste, but you can just still see, only one of these blocks ever is supposed to execute. So we give the first one a chance. We jump into it if it's true. If it's not true, then we give the second one a chance. We jump into it if it's true. If not, we jump to compare. The third one, if it's true, then we jump to its scope. If not, we jump to the else. And the else always executes if nothing else above was true. So that's the basic idea here. Oh dear, I've probably lost my place. Looks like I just copy pasted less 10 true, which was this right here. So less than true or less than 10 true. Okay, so we told the user your stuff is less than 10. And then we jumped to the done area. So that means we are probably working on the else area. Okay, let me grab that. So now finally, we're going to have the else area, which is going to, finish this all up. That's going to be after the if done. So if nothing else matched, then we will end up jumping to the else area, and then we'll basically just tell the user none of the conditions seemed to have applied. And then even at the end of the else block, even though you could probably get away with just letting execution fall through, just to save yourself one instruction, you could comment that out, assuming you were sure that the very next instruction was the beginning of the done area. But otherwise, I'm just going to play it safe and jump directly there. Then we have to make the actual done area. So just so you know, a label doesn't have to have any instructions. We could have something like this: if else test say goodbye. We could have two labels right next to each other and one doesn't actually have instructions. That's totally fine. If you jumped to the done area, then execution would just fall through to the next valid instruction, which could go through another label. So we could have a say goodbye label and an if done label. I'm just gonna have the goodbye stuff happening inside of the done. But for clarity's sake, you might want to keep that label in there that I just deleted. And all that we need to do at the very end, when we're done with everything, is just say goodbye. So I'm just printing a message. So just to do a quick recap here, let's see. We come in with the user's input as R12. We ask, does R12 equal 5? If that's true, we'll say that it was equal to 5. And then we'll go to the done area, meaning we'll skip past all the other blocks for the if-else block, or all the other scopes. But if that did not equal 5, then we'll fall through to that jump instruction, which takes us to the next test, which is going to be our else if equals 6. So we are checking now to see if R12 is equal to 6. If that's true, we jump to this next block. Why do we need to jump to a block that's so close? Well, if we don't, then we're going to end up definitely jumping to the next comparison, and that wouldn't work. So we're just kind of jumping over this unconditional jump statement, and we're saying, all right, your your input was definitely equal to 6. And then we're jumping to the done area, just past everything. But if that wasn't true, then we hit this unconditional jump that takes us to the next comparison to see if the user's input was less than 10. And so, if that's true, then we go to the true area to print another message and then go to the done area. If it was false, we fall through to the else jump, which will take us to here. And notice how the else scope doesn't actually make any comparisons, because, when you have like an when you have an if, else if, else if, else if, any number of else if blocks, the else will always be executed if nothing above it actually did execute. So if you have an else block, that means something will execute. So we're not doing any comparisons. We're just saying, when that scope is done, we're just going to jump to the done area. So all of these different scopes, they're jumping to the done area when they finish. And the done area is just this label right here where we say goodbye. And that's it. Let's see, did I copy paste everything that I was supposed to? I think so, probably. So let's run the program and see if it works. Okay, let's just enter the number 3. All right, it at least compiled. So the basic if test, that was the first part of either this video or the previous video, depending on whether I chose to split this up. So let me comment out those calls real fast. So I'm going to just comment out these calls real quick so we can only deal with the complicated if-else block. So I'm going to enter like a 3. Whoops, let me do it again. 3. And so begin the if-else test. Your input was definitely less than 10. And then we end the if-else test. So notice how only one scope executed. 3 was definitely less than 10. What other numbers did we have? Let me write them down somewhere so I don't forget. Oh, they're written down right here. So we entered a 3, which was definitely not a 5 and not a 6. So that's why the less than 10 block executed. Maybe I should pin this. Right. So now if I enter a 5, only the first scope should execute. So it says your input was equal to 5. Notice how it didn't mention that it was a 6 or less than 10. And then if we do a 6, it should just tell us that we have a 6. It will not mention the 5. It will not mention the 10. So we did 5 already, and then we did 6, and we did like a 2, which was less than 10. We could also do a 1, which was less than 10. We can do anything that was less than 10. And then the else would be if our input is probably like 11 or greater, meaning it's not less than 10, and it's also not 5 or 6, just so we can see the else block. So I'm going to do 11, which is the first number that should trigger the else block. And it says no conditions were satisfied, which was the message inside of our else block. Let me just show you that again real fast. This was the else block. So message, if, else, else. Poor labeling on my part, I realize that. But it basically says no conditions were satisfied. The if, else, else. I think that's basically everything that I wanted to show you. At this point, you should feel like you're starting to become an expert at complicated if, else blocks, converting those from a higher level language into assembly. And I honestly recommend that you practice this like crazy while you're trying to get more used to it. But hopefully you have everything you need at this point. Keep in mind, I've said this at the beginning. I think I said this in a different video. When we use these branching instructions, notice how I have jump equal to, where's that less than? Yeah, notice how I have a instruction jump less than. The family of conditional branching instructions that compares less than, greater than, less than or equal to, greater than or equal to. The ones that I'm using here apply to signed integers, and they won't necessarily work with unsigned integers, and they won't work with floats if you compare floats later. So just keep that in mind. Let me pull up my favorite book again real fast. Where the heck is that book? Oh, dude. Where's my document viewer? Document viewer. Can I get... There we go. So I guess I didn't introduce this book at the beginning of this video, but I probably should have. This is my favorite assembly book. You can turn yourself into an expert with this book by just on its own. It's open source and free. The author gives this away. He's a genius. The person who wrote this book is Dr. Ed Jorgensen. He's a professor. He wrote this for his own classes, and again, it's like a free open source book. You can just download a copy from his website if you look this up. and convert yourself into an expert. So let me collapse everything here, and then I'll go to instruction set overview, control instructions, conditional control instructions. And I just want you to see real fast, just as a recap, I talked about this in a previous video, but when it comes to comparing things and checking if they're equal or not equal, it's the same for signed or unsigned operands, because if you want to see if two operands are equal, you just check to see if all of their bits are equal. You don't even really care whether they're both integers or not. On the other hand, notice how there is like a family here: jump less than equal to, jump greater than equal to. Those instructions apply only if your operands are signed integers. They have a plus or minus sign. If they are unsigned, or if you're using floats for your comparisons, you have to use this other family of conditional branching instructions called jump below equal, jump above equal. And I'm sure you can infer that jump below is the same thing as jump less than, right? Jump less than or equal to is the same thing as jump below or equal to. It's just that you need to use a different instruction if you're using signed integers or floats versus, sorry. You need to use different instructions if you're using signed integers versus unsigned integers or floats. So keep that in mind. The code demo that I just showed you, it's for signed integers. If you were going to use unsigned integers or floats, this program wouldn't work for you. You'd need to replace my branching instructions with the unsigned versions, which, I mean, they work the same thing. You're still going to do a comparison instruction, so it still works. Anyway, so after having shown you that and making sure that everything actually did work, I think we've talked about everything that we need to for this video. So yeah, I hope you feel like an expert. Practice this on your own, write your own programs just to make sure you know how to convert a higher level language block into an assembly block, and you should be on your way. Thank you for watching this video. I hope you learned a little bit of stuff and had a little bit of fun. Tell your friends. And I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community, so we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? Just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.